One of the problems in section 7.5 essentially turns around using the angle addition formulas. It starts out with sine of pi fourths times the cosine of 7 pi twelfths minus the cosine of pi fourths times the sine of 7 pi twelfths. It asks you to find the exact value of that. What I noticed when I first looked at this is that it had a sine and a cosine and a sine and a cosine, both using the same angles but mixed. So that made me think of the sine angle addition formula. Because it had a minus, that tells me I'm going to have a minus in the, I'm going to use the angle form of the angle addition formula that's got minus in it. And so I can rewrite the expression at top as pi fourths minus 7 pi over 12. And since pi fourths is the same as 3 pi twelfths, this is negative 4 pi twelfths, or the sine of negative pi thirds if I put that in lowest terms. Since sine is odd, I can rewrite that as the sine negative 1 times the sine of pi thirds. And the y value at pi thirds, if you're looking at the unit circle, is root 3 over 2. So the answer is negative root 3 over 2. Of course, you knew what pi fourths was at the start, but you couldn't have gone the long way on this problem and figured out what each of the four angles were because you don't know directly what the sine and cosine of 7 pi twelfths are. So the easiest way to do this, just notice that those four trig functions in the first line can be combined into a difference of the sine of two angles.